I'm going to look at the answers to worksheet 4.2, Lewis structures. Question 1, fill in the following chart. So in this chart, you're given an element, the number of valence electrons you were supposed to write down, and then identify the number of dots on the electron dot diagram, and then the charge that that element would have. So hydrogen was already done for you. Lithium is in group 1, so it has 1 valence electron. Beryllium is in group 2, it has 2 valence electrons. And what am I talking about these groups? When you look at the periodic table, a little wiggly wiggly there, everything in group 1 or 1A has 1 valence electron, or it'll have a 1 plus charge. It'll lose that 1 valence electron. Everything in group 2 or 2A has 2 valence electrons, and they'll lose those 2 valence electrons to become 2 pluses. And then as we are obviously skipping the transition metals, and then we're going to go over here and we'll really pick it up at about group 5A. So these have 5 valence electrons, all these elements, but for the most part we're concerned with the nonmetals when I'm talking about this. Carbon does have 4 valence electrons, and these ones have 3 valence electrons. It's true. So 5 valence electrons, and it wants 8, so this will have a charge of a 3 minus, because 5 plus 3 is 8. Oxygen is in group 6. These elements all have 6 valence electrons, but to reach an octet, 6 plus 2 is 8, so these are a 2 minus. Then everything in that group is a 1 minus, so it goes 3 minus, 2 minus, 1 minus. So let's go back and look at this chart. So aluminum has 3 valence electrons, nitrogen has 5 valence, oxygen has 6 valence electrons, and bromine has 7. The dots that you would write around all of these are the same as the valence electrons. So those charges, it has 1 valence electron, it will lose it to become a 1 plus. 2 valence electrons, it'll lose those 2 to become a 2 plus. Aluminum has 3 valence electrons, it's metal, it will lose those 3 to become a 3 plus. But nitrogen's a nonmetal, and it's easier for nitrogen to gain 3 electrons, so a 3 minus to reach an octet instead of lose to its inner shell below the one that you're already in. Oxygen has 6 valence electrons, it would prefer to gain 2 electrons to become a 2 minus to reach 8, and bromine has 7 valence electrons. It's easier for it to gain 1 electron to become a Br 1 minus to reach its 8 electrons. So now let's look at these Lewis structures for ionic compounds. And the answers are written there for you, but let's go over them to see if we can do this. So how would I start with this? You would start with sodium, and it has 1 valence electron, and then you would start with fluorine, and it has, we already did that color, 1, 2, 3, 4, 5, 6, it has 7 valence electrons. So this electron will go over there, it'll be lost, and that becomes an Na plus because it loses that 1 electron, or you could kind of cheat and find sodium and go up to the top, it's a 1 minus. And then that fluorine, I'm not writing these in the order I should be, will now have 1, 2, 3, 4, we should make these bigger, these are getting crazy people. And then it will have, what was that one? It was blue. I lost my blue. Please, people, let me have my blue. And that one will be there. So you put these ones in a bracket to hold them in, and you gained 1 electron, so it becomes a 1 minus. Again, that rendition looks much better than my rendition. The next compound on here is MgO. So we would start out with, like Mg, it has 2 valence electrons because it's in group 2, and then we would have oxygen, which is in group 6, so it has 6 valence electrons, 1, 2, 3, 4, I'm not drawing these in there properly, am I? 5, 6. So these 2 valence electrons are lost over to that, and so that becomes an Mg2 plus because it loses those 2 electrons. That oxygen now has 8 valence electrons, put them in the cage to hold them in, and it gained 2 electrons, so it's a 2 minus, hence the Mg2 plus and an O2 minus. I don't know if I'd put that plus sign in there or not, but it's in there for that one. Now we're going to look at MgF2. So Mg would have 2 valence electrons because it's in group 2, and then fluorine still has 7 valence electrons because it's in group 7. So 1, 2, 3, 4, 5, 6, 7. And it says we actually have 2 Fs, so I need to be a little more cognizant of that. So this is what it ended up looking like that. And so one valence electron will go there, another valence electron will go there, and it ends up looking like Mg, that one Mg loses 2 electrons, so it's a 2 plus. You can draw it like here. I prefer to draw it such that I have 2 Fs, and I got to put them in brackets because you always put that nonmetal in brackets. So 2 Fs, and they all have 8 dots around it. If you haven't noticed, that's the secret of this nonmetal on this side, and it's a 1 minus charge. There's a kind of a fun little way to check. So in front of this Mg is an unwritten 1. So 1 times 2 is a 2 plus, and that must be equal and opposite of this next one, which is 2 times a 1 minus, which is a 2 minus. So the charge cancels out to be 0, which is what you want, and your final answer would look like that. That's also acceptable. I prefer to do it with the 2 in front. It's a little bit easier. Letter D here has 2 Ks and 1 S, so we'll draw a K and a K, and it is in group 1, so they each have 1 valence electron. I should have started at the top with those dots. And then there's 1 S, and the S is in the, here we go, the 6th column, so it has 6 valence electrons, and let's do this one a little bit different color. Ooh, that's a highlighter, people. So we have the S, which is going to have 6, so it's going to be 1, 2, 3, 4, 5, 6. So let's look at these. The metal is going to transfer to the nonmetal, so this one could go in that slot, and this one could go in that slot. So each K, so I'm going to say we have 2 Ks, and each of those individual Ks lost 1 electron, and the sulfur gained 2 electrons. We got to put those in a cage so they don't escape, and it gained 2 electrons, so it's a 2 minus. So I like to check. A 2 times a 1 is a 2 plus, and an imaginary 1 in front of here times a 2 minus is a 2 minus, so a 2 plus and a 2 minus cancel each other out. So your final answer looks like that. This next compound is Al2O3. So we have 2 Als. I prefer to write it 2 and then Al. You don't have to put brackets around those ones, but they did. And then there's 3 oxygens, so 3 oxygens. And let me write this. So I'm going to have Al, and each Al has 3 valence electrons. I think I'm going to squeeze another one up here. Al, 1, 2, 3. Oh, they look terrible. Sorry, 2, not 3. What in the world am I saying? And then we have 3 oxygens. So we'll go to the oxygens. 1, 2, 3, and they each have 6. So 1, 2, 3, 4, 5, 6. So the rest of them, we know what they look like. It's really no good having circles with circles, is it? Maybe those are planets with planets. So I think this aluminum will go there. That one will go there to pair up. And then this one will go there. That one, I think I messed something up on that one. 1, 2, 3, 4, 5, 6. I think I did. One will go there. And then we have 2 more. One will go there and one will go there. I put too many dots on some of those. So anyway, it ends up looking like 2 Als, and each Al lost 3 electrons, hence it's a 3 plus. And you have 3 oxygens, and each oxygen gained 2 electrons. That's why it's a 2 minus. So 2 times 3 is a 6 plus, and 3 times 2 is a 6 minus, equal and opposite. And again, this is how you write the ionic Lewis structures. You'll always have a metal on this side, a nonmetal on that side. The nonmetal always has 8 dots around it. This one has the charge for the group that it is in up here, and this one also has a charge on the superscript, not necessarily for the group, but you can figure out oxygens here. It takes 2 steps to get to 8, and that's why it's like that. So now we're going to move on to covalent compounds. For covalent compounds, we're going to write each of the atoms with their valence electrons to start with. So we have 2 hydrogens. So I have a hydrogen, and I have a hydrogen, and each one has 1 valence electron. And then I have an oxygen, and oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, 6. And I see that my next step is I'm going to try to connect them. I think that this pairing of electrons might be shared, and I think then that pairing of electrons might be shared. And the single element always goes in the center, so that oxygen is going to be in the center, and it is going to have a completely filled shell. And then those hydrogens will be on either side. And the electrons that are shared, these ones there, we tend to draw them as lines. So we will write it as hydrogen, shared electrons, oxygen, shared electrons. And then we'll make sure you keep your dots, those are called the lone pair electrons, on that hydrogen. And this answer here is written because someone who did this knows that there's something special going on about water and the angle and the shape of it. But in general, if you ended up like this, a hydrogen, some 2 electrons for bonding, lone pairs on the top and the bottom, shared electrons, which would be 2, and a hydrogen, that would be great. And then we can even check hydrogen, if we look at just this part, has 2 electrons, which is going to make it happy. That hydrogen is going to have 2 electrons also, which is going to satisfy its duet. And then we look at just the oxygen, and it has 2, 4, 6, 8, which satisfies its octet. So it has completed what it needs to do. And so really and truly, it looks like this: hydrogen, oxygen, hydrogen. And we'll move on to the next one. The next compound on here is hydrogen, H2. So you'll have a hydrogen, and that one has 1 valence electron. You'll have another hydrogen, that one has 1 valence electron. They will share those 2 that we will represent with a line, and it looks like that. The next compound is Br2, so you would write a Br and a Br and put your dots around it. They each have 7 valence electrons, and so they would share that pair, which then makes the line of the shared electrons, and then it'll have all of these lone pair electrons. So a question I might ask you on your test is, how many lone pair electrons does one of the BRs have? So you would go here and you'd count. It has 1 pair, 2 pairs, 3 pairs. So 3 sets of lone pair electrons for 1 BR. There's 6 pairs total, but 3 for 1 BR. The next compound is CF4. The C is in the middle because it's the single item, and carbon has 4 valence electrons around it, and then it'll have the 4 fluorines around it, and each fluorine will have 7 valence electrons. I didn't finish filling them in. This looks like a mess. And then there's going to be some sharing going on. Looks like maybe those two will share, those two will share, those two will share. I forgot to put one on this one. And then those two will share, and it ends up with 4 bonds, 1, 2, 3, 4. And then you'll have 4 Fs with 6 dots around each one of those. And then you check, does everyone have 8? Fluorine has 2, 4, 6, and that orange line is 8. And they're all identical, so they all have 8, but let's check carbon, 2, 4, 6, 8. If you haven't noticed, it's 4 sets of 2 things surrounding each element that adds up to 8, unless it's hydrogen or boron. This next compound is BBr3. B is one of our exceptions. It has just 3 valence electrons, and it will want just 6 in total. I'm not sure why I put that one there, but I did. So 1, 2, 3, and then each of those BRs will have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. And so that'll be shared, that'll be shared, and that'll be shared, and then it ends up looking like this. Boron, and boron just wants 6, so there's 2, there's 4, there's 6, and then each bromine will have 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. This last one is NH3. The thing in the middle is the single one, and nitrogen is in group 5, so it will have 5 valence electrons. 1, 2, 3, 4, and a 5. And then we have 3 H's. I'm going to put an H there, an H there, and an H there, and each H has 1 valence electron. And then we look at who is sharing. That one will be shared, that one will be shared, and that'll be shared, such that you'll have nitrogen in the middle, and there's your shared one there, there's that shared one, and there's that shared one, and you'll still have these lone pair electrons on the top, and then we count each hydrogen wants to be 2, so that one has 2, that one has 2, that hydrogen that's hiding has 2, and then the nitrogen will have 8, so there's 2, 4, 6, 8, and then it is complete, and that is called NH3.